This is Module 2, Lesson 5, Part 2, and we're going to be talking about normal probability distributions. But before we can really talk about normal probability distributions, we need to kind of have an understanding of what is a probability distribution and why do we even need them. Earlier in this module, we talked about a grouped frequency distribution as it related to quantitative data. A frequency distribution gives us an idea of what actually happened when we collected the data. A probability distribution, on the other hand, describes what will probably or what should happen theoretically instead of what actually did. And a lot of decisions that are made in business, insurance, and other real life situations are made by assigning probabilities to all the possible outcomes pertaining to the situation and then evaluating the results. For example, a scenario analysis, worst case, the likely case, the best case. Sales forecasting and risk evaluations, determining, what's the chance you're going to make a specific number of sales within a given time period. What's the risk of buying a certain stock? Is it going to go up? Is it going to go down? Rates of returns on stocks, standardized test scores, the lifespan of different consumable items like light bulbs and batteries. So there's a wide variety of applications in the real world for probability distributions. One of the most important probability distributions that exist, it's not the only one, but one of the ones that we use quite often is the normal distribution. A normal distribution has some very important characteristics. First of all, it is continuous, which means you have a smooth curve. It's connected with no gaps or breaks. You can actually put your pencil on the paper and draw the entire curve without lifting your pencil. Additionally, the normal distribution is symmetric, which means the left side and the right side are mirror images. If you could fold it in half, you couldn't tell the left from the right. It also means, as we learned earlier, that it is unimodal. There's one mode, and the mean, the median, and the mode are approximately the same value for a symmetric distribution. The normal distribution is also bell-shaped, meaning that the majority of the data values are in the middle and the amounts taper off on both the low and the high end. There are actually an infinite number of normal distributions that can exist because the shape of this normal distribution, although it will always be bell-shaped, continuous, and symmetric, is actually determined by the value of the population mean and the value of the population standard deviation for a given scenario. Furthermore, one of the key things about a normal distribution is that the total area under the normal distribution is equal to 1 or 100%. This is kind of a carryover from the probability rule that the sum of the probabilities of all the outcomes in the sample space is 1. Now, we can actually prove that the total area is 1, but it requires us to know calculus. So you may have to trust me on this fact. There's a special way that you can write the information related to a normal distribution. In word form, it says if X is a quantity to be measured that has a normal distribution with a mean, mu, and standard deviation, sigma, we can write it kind of in a shorthand. We write X, and then a little wavy line, it's called a tilde, X, wavy line, N for normal. In parentheses, we list the population mean first, always, comma, and then the population standard deviation, and we close the parentheses. It's just a shorthand for indicating that information related to the normal distribution, because you have to know those two things whenever you're dealing with a problem. Prior to the advent of technology, we would have had to use a table to help us to interpret a normal distribution, which would have required us to convert everything to the standard z-score. Lucky for us, we have technology, and so we're going to look at how to use that in just a few minutes. One of the rules that relates to a normal distribution is called the empirical rule. And the empirical rule has several uses in relationship to a normal distribution. It actually tells us or gives us an idea of the percentage of values within a certain range of the mean, which is, again, it's kind of the z-score and a measure of position. The empirical rule can also be used to determine if your sample is from a normally distributed population. It's an important rule in statistics because the concept of going out about 2 standard deviations to get about 95% of the values is one that we see often when we talk about confidence intervals and hypothesis testing, which you'll be doing in modules 3 and 4 in this course. So you need to have kind of a basic understanding of the empirical rule. The guidelines for the empirical rule are this: about or approximately 68% of the data values are within 1 standard deviation of the mean. So the mean is in the middle, and if I go 1 standard deviation below and 1 standard deviation above, which is kind of this turquoise colored region here, that's about 68%. Now remember, because this is symmetric, that would mean, half of the 68 is to the left and half to the right. So it's 34 if I go 1 below and 34% if I go 1 above, for a total of 68. Then if we go 2 standard deviations from the mean, 2 standard deviations below or 2 standard deviations above, we have about 95% of the data values are within the mean, about 95% of the data values are within 2 standard deviations of the mean. And then if we go 3, about 99.7% of the data values are within 3 standard deviations of the mean, which kind of means if we have something that's more than 3 standard deviations from the mean, we may want to take a look at it because that could be a possible outlier. It could be a miscalculation or something, because it would be very unusual for a value to be more than 3 standard deviations from the mean. So let's take a look at how we can use this empirical rule. It can help us set up some fence posts. There's lots of different applications to it. The scores on a college entrance exam have approximately normal distribution with a mean of 52 points and a standard deviation of 11 points. About 68% of the scores on a college entrance exam would lie between what 2 values? Well, the empirical rule states that 68% lie within 1 standard deviation. So if I calculate the mean plus or minus 1 standard deviation, we would have 52 plus 11 is 63, which would be your high, and 52 minus 11 would be 41. So about 68% of the scores on a college entrance exam would lie between 41 and 63 points. If we want to know about 95% of the scores, 95% corresponds to being 2 standard deviations away from the mean. So if I perform those calculations, I would have 52 plus 2 times the standard deviation of 11, which will be 52 plus 22, that's 74, which will be your high. And then you do the same thing, which you subtract 52 minus 22 would be 30. So 95% of the test scores should fall between 30 and 74. And then finally, 99.7% or virtually 100% of the scores would fall between what 2 values? The empirical rule implies that would be within 3 standard deviations. So if we calculate within 3 standard deviations, for the high, we would have 52 plus 3 times the standard deviation of 11, which is 52 plus 33, which equals 85. And then you subtract as well. So 52 minus 33 is 19. So the range of values would be from 19 to 85. So we should anticipate that virtually anyone who took the college entrance exam should score between 19 and 85 points. But what if we want to know the percentage within half of a standard deviation of the mean, or within 2.75 standard deviations of the mean? Then the empirical rule really doesn't apply, because it only gives us one standard deviation, two standard deviations, or three exactly. So the empirical rule doesn't help us, but we can use what we know about the normal distribution, as well as our calculator or possibly a free website, to determine such percentages. And so we're going to take a look at how to do that in the next video. And in the problems that follow, you're going to see phrases like probability, or area under the curve, or percent, or percentage. And I want you to remember that those words would be synonymous in the questions. They're all asking you to calculate the same thing.